Hi everyone. In this video, we're going to talk more about rational functions, and in particular, we're going to talk about vertical asymptotes and holes, and how I can tell the difference. So we have an example here. Our function r of x has a bunch of terms in it, and our goal is going to be to find all of the roots, holes, and vertical asymptotes. Now, a lot of the time we use the term zero in term of root, but I think in this video, calling them roots is going to give us a little bit less confusion. Okay, so let's go ahead and start there. We've had in the previous few videos talked about how to find those roots, and what we need to do is we need to look at the zeros of our numerator. And so in this case, if I look at all my factors, x, this gives me a root of 0, x plus 1, this gives me a root of -1, and x minus 2, this gives me a root of +2. So the candidates that I have for my roots are 0, -1, and 2. Right, so I'm going to put little question marks under these because they're candidates. These are things that are possibilities. And so what I'm going to do is then quickly go down into my denominator and say, well, 0 also appears down here. So this is not one of them, right? So this is not a root. It's going to be something else. That means it's either going to, since it appears in the denominator, it's either going to be a hole or a vertical asymptote. So we'll think about those. So same thing with -1, also appears in the denominator. So it is not a root. And the only root that we have is +2. So I'll erase that question mark. We see we do have a root at +2. So what I'm going to do here, once we think about this algebraically, we're going to bring it up on Desmos and verify everything graphically. Okay. So now I'm going to think about holes and vertical asymptotes. And the way I decide is, well, I look at my denominator. So as we said, the candidates for vertical asymptotes, the candidates for roots, we looked at all the zeros of our numerator and we said those were candidates for roots, and then we eliminated some of them. What I'm going to do is look at candidates for vertical asymptotes. So the zeros of my denominator, which are candidates for vertical asymptotes, are 0, -1, and +3. So 0, -1, +3 are candidates for vertical asymptotes. So what I'm going to do next is I'm going to take my function r of x and I'm going to look at the reduced form. So I'm going to come up here and I'm going to start canceling out things that are in common. Right, so this x term cancels out with one of these x terms down here, leaving just an x in my denominator. The x plus 1 squared, one of those cancels with the x plus 1 term in my denominator. Well, it looks like that's all that cancels. So my function r of x is this x plus 1, x minus 2, divided by x is x minus 3. Okay. So we had some candidates for vertical asymptotes. We wanted to check 0, -1, and 3. And once I'm in my reduced form, I just have to check, are these still zeros in my denominator? Okay, so my candidate over here, 0, does its factor still appear down here in my denominator? Turns out it does. So 0 is a vertical asymptote. -1, does its factor still appear down here in the denominator? Turns out it doesn't. So this one is not a vertical asymptote. Okay, so let's go ahead And let's X this one out. 3, does its factor still appear in my denominator? Turns out it does. Right, so these are my vertical asymptotes. And, well, the only thing left over are wholes. Right, so we should have a whole at -1, right? So if we clean this up, we should have a root when x equals 2. We should have vertical asymptotes when x equals 0 and when x equals 3. And then we should have a whole when x equals -1. Okay. So I'm going to pause this for a sec, and then I'm going to bring up Desmos so we can verify all of this information. All right, so I cleaned everything up. I left our results over here on the right-hand side of the screen. And I have our Desmos window open here with our function. So our function r of x was x times x plus 1 squared times x minus 2, all divided by x squared times x plus 1 times x minus 3. So we looked at this function and we said it should have a root at +2 when x equals +2. It should have vertical asymptotes when x equals 0 and when x equals 3. And should have a whole when x equals -1. All right, so if I come around and I look at my graph, we do see that we in fact have a root when x is equal to 2. So this is a point on our graph. Everything looks great with our roots, except if I look over here, it seems like I should have a 0 or a root in here somewhere. But if I find it, -1 is undefined. So I have a whole at -1, which is exactly what I wanted to see. And then our vertical asymptotes when x equals 0 and when x equals 3, we can see here. So let's zoom in just a little bit so we can get numbers up. But we can see that when x is equal to 0, we get this behavior that we're looking for, right? So our outputs are going off to infinity. And same thing here at 3. We can see that our outputs are getting very, very, very large. They're growing unboundedly. So that's great. It's exactly what we wanted to see. Right, so what we did is we looked at our function and we identified the roots by looking at the zeros of the numerator that did not appear in the denominator. And then when we went to see vertical asymptotes and wholes, we looked at the zeros of our denominator. Okay, so when we looked at the zeros of our denominator, there were a couple things that could happen, right? We made them all candidates for vertical asymptotes. So we said our candidates were 0, -1, and 3. We said, okay, these are possible vertical asymptotes, but in order to verify, we had to reduce, right? So we looked at our reduced form, and so when we did, when we reduced, we saw that, well, -1 didn't remain, it didn't stick around. And so since it didn't stick around, we said, hey, that's a whole in our function. X equals -1 is going to be a whole in our function. Right? So this process, going through this way by looking at the zeros of your numerator and denominator, is a fast way, an algebraic way, to identify your roots, your vertical asymptotes, and your wholes. So in the next video, there's one more type of asymptote that I want to talk about that's called a horizontal asymptote, and you can actually see it in this graph, right? So if I zoom out just a little bit here, right? So if I zoom out, what you should observe is there's this horizontal line here that, well, when x gets very, very, very big, or very, very, very big in the negative direction, that our outputs start to get really close to 1. Right? And so we're going to see how we can identify horizontal asymptotes moving forward. See you then.